Hello everyone. This video is about a new product that I've been working very hard on. It is an audio component isolation stand, originally meant for turntables, but it will work on any audio component. It can be reconfigured with different parts in order to suspend almost any weight. Right now I'm suspending a total of 50 pounds via two 25-pound exercise weights, and that's well within the capability of most turntables out there anyway. What we have here is a 8-inch woofer being driven at 2 Hertz, 2 cycles a second, with 5 volts of sine wave energy. We also have a glass filled with about ½ inch of water sitting on the suspended platform, and the woofer is sitting on the base of the isolation stand, so it's driving the bass section. I don't mean speakers, but it's driving the bass portion of the isolation stand. And so right now it's moving at 2 cycles a second, which is the approximate resonant frequency of this isolation stand. I can verify that. You won't be able to see it too well at this angle, but if I try to time this with the movement of the woofer, you can see it syncs up fairly well. Maybe you can, I don't know. But anyway, let's get on with the isolation part of it. But before I do that, I want to show you what kind of sensitivity this glass filled with about ½ inch of water exhibits. Right now this is just a plastic drinking straw, and the camera is located about 15-16 inches away from the isolation stand. This is the isolation platform here, and the glass is sitting on the suspended platform. So I'm going to blow through this straw at a distance of about 17 inches, which is approximately the same distance as the camera lens is from this guy right here, and to give you an idea of how sensitive this test will be. So you'll look for disturbances on the surface of the water, and what we have here is my overhead LED light, and when I zoom in, you'll see multiple little LED reflections in the water. So pardon the camera, but it just simply doesn't zoom very easily without getting pretty touchy. That's about as smooth of a zoom as I can do. Okay, so what you'll see there is a multiplicity of individual LED lights reflecting off the surface of the water. And here's how sensitive it is. Again, plastic drinking straw at about 17 inches, 15 to 17 inches away from the glass of water, and not blown hard at all, just a gentle puff of air through there. Okay, it is a subjective test. We're not generating any hard data from this, no numbers, anything like that. However, it's a very sensitive test. Give you another idea how sensitive this glass of water is with the reflection. Okay, let's get on with this. We're going to do a frequency sweep, and starting off at 2 Hertz, which is what it's running at right now, and let's get on with this. Okay. So this is what you're witnessing right now is 2 Hertz, 2 cycles a second, with also ambient noise. Remember, in our environment we have all kinds of low frequency noises going down into the infrasonic region, and so what you're witnessing right now is the isolation of this stand, not only to this woofer running at 2 Hertz, but to all the other wide spectrum noise components in our environment. You can see it's pretty darn stable and calm on the surface of that water. Here we go. And I'm going to call out the frequency here, and hopefully you can hear me because I have to turn away to read the frequency readout on my sine wave generator. 2 hertz. Sweeping up. 3 hertz. 4 hertz. 5 hertz. 6 hertz. 8 hertz. 9 hertz. 10 hertz. 11 hertz. 12 hertz. 13. 14. 15. 16. 17. 19. 20. 21. 22. 23. 24. 20. We're still at 24. I'm going to switch to a different scale here. 17 hertz. 18. 23. 25. 27. 29. 32. 34. 36, 39, 41, 45, 49, 53, 56, 60, 65, 68, 71, 77, 82, 88, 91, 98, 105, 112, 119, 128, 135, 141, 144, 154, 160, 163, 168, 180, 186, 190, 193, 202, 209, 215, 227, 229. Switching to the next scale. 170, 180, 215, 236, 254, 273, 291, 331, 360, 373, 394, 411, 429, 447. Now I'm stopping at 447 or approximately 450. There's no point going any further. I can, if you like, but really that's really the function of the isolation stand to prevent frequencies, well below that frequency. Anyway, so there you have it. We see a graphical representation of the isolation qualities, the ingress qualities of this isolation stand. Also too, I can take my fist and I can bang on the bench. I mean, I'm hitting the bench really hard. And yeah, you see some movement there, but you'll notice it's very low acceleration, low frequency movements. And any isolation stand is a low pass filter. So meaning that as ingress frequencies occur above the resonant frequencies, it progressively absorbs those frequencies and prevents the pass-through. So obviously at some low frequency it's going to let a little bit through, but your objective is to get that frequency down as low as possible. So anyway, again, I'm smacking this bench really hard, and those accelerations that you're witnessing there are not only I consider to be relatively small, totally reasonable and manageable, but also of a very low frequency. Okay, I'm going to try and reposition the camera without, fudging it up too much. All right. But this video is not meant to be a complete introduction to this stand. I just wanted to demonstrate its isolation properties. Okay, let's see here if we can go ahead and show more of it in a way that doesn't have a bunch of jerking characteristics. All right. And I'll provide a more of a description. Also, as in all my videos, you have to read the text, otherwise you won't understand what I'm trying to do here. So I need you to read the text always in all videos, including this one. So let's see, am I fully zoomed out? Yes. Okay. And I got to reposition the tripod. And I'll get a ad drawn up for this on my Webstore account here sometime as soon as I can, if I can ever get caught up with all this turntable work that I'm doing. Okay, that's all I'm going to show right now. As you can see, it does have vertical stanchions, and it is a hanging suspension topology. Like I already said, I'm not doing any compression suspension designs for my top of the line. I am for my bottom of the line offering, which I have to do a video on that too. But this is my top of the line, and I'm calling it the NSP-1. So, okay, thank you very much. Take care.